Okay. Question number 15 part B. What will be the resistance of a metal wire of length 2 meters, area of cross section eto, if the resistivity be eto? Dekho, we know that the formula is R equals rho times L by A, right? What is rho? What is rho? Rho is resistivity. What is R? R is resistance. What is L? L is length of the conductor. What is A? A is area of cross section, right? So according to the question, we have been told to find the resistance, right? Or resistance R equals to rho will be 2.8 into 10 to the power minus 8 times length is given as 2 meter divided by area is given as 1.55 into 10 to the power minus 6. Okay, so we will do a calculation of it. Whatever the answer will be, that will be the answer. Okay, let me take the calculator. So that will be 2.8 times 2 divided by 1.55. So 3.61. So 3.61 into 10 to the power minus 2, or it will be 0.036. This is the answer. Okay, all of you write this down. How does the resistance of a wire vary with its area of cross section and diameter? Now first we will understand that resistance R equals to rho times L by A, or it means that R is inversely proportional to area, right? R is inversely proportional to area, or can we say that or if the area will increase, if the area will increase, the resistance decreases. The resistance decreases. Okay, this is A. The B part is saying how will it depend on diameter. See, R equals to rho L by A. Now diameter does not affect the length of the wire, right? Does diameter affect the length of the wire? No. That means it will only be depending on the area. Resistivity is a constant, or in this case also R is proportional to 1 by A. Now suppose you are taking a cylindrical wire. Okay, if the resistance of the radius of the wire be smaller, then what will be the area? Area will be pi times smaller square. Am I clear? Or that will be pi times, okay, radius, can we write radius as diameter by 2, so its whole square, so that will be pi by 4 times diameter square, right? Now if I place it here, what am I getting? Or R proportional to 1 by pi by 4 times diameter square. Now pi is a constant, right? 3.14. 4 is also a number, so that is also a constant. So can I write this as R proportional to 1 by d square? So that means resistance of a wire is inversely proportional to the square of diameter of a wire, that means if diameter increases, resistance will also increase. If diameter if diameter increases, the resistance will decrease, right? Are we clear here? Okay. How does the resistance of a wire change when its length is tripled, its diameter is tripled, its material is changed to one whose resistivity is 3 times? There are 3 cases. Now we will deal with case 1. See, R proportional to L. If L is tripled, will the resistance be tripled? Are we clear? Okay. Let us make it in this way. Can I write R2 by R1 equals to L2 by L1, because it is proportional, right? Or according to the question, what are they saying? They are saying that L2 is 3 times L1. So can I write it here as R2 by R1 equals to 3 times L1 by L1? If I deduct the L1s, or R2 will be 3 times R1. Are we clear? Okay. Now they are asking about the diameter. If its diameter is triple, just before some time we did a relation that R proportional to 1 by d square, right? Just before some time. So can I write R2 by R1 equals to d1 square by d2 square? Can I write them? Now they are asking that if the diameter is triple. Now d2 equals to 3 times d1 then if the diameter is triple, right? Or can I write it as r2 equals to d1 by 3 d1 squared times r1. See, can I write it as d1 by d2 then square? I am putting 3d1 in place of d2, right? So what am I getting? d1 by 3d1 square. So d1 cutouts. So we get r1 by 9, or R2 will be initial resistance by 9. Now they are asking its material is changed to one whose resistivity is same. That means, see, we know that R equals rho L by A, right? Now they are saying that the resistivity itself is changing. By how? By we are just changing the material, okay? So if you are changing the material, then can I write R2 by R1 will be rho 2 L by A by rho 1 L by A, because L and A's are not changing, right? So this deducts away, or we get simply rho 2 by rho 1. Okay. Now they are saying that the resistance is 3 times. The new resistance is 3 times the resistivity is 3 times the old resistivity. That means rho 2 is 3 times rho 1, right? Or R2 by R1 will be 3 rho 1 by rho 1, or R2 will be 3 times of R1. Are we clear here? R2 is 3 times of R1. Okay. Okay. The electrical resistivities of 4 materials A, B, C, D are given below. Okay. Now tell me, if resistance R equals rho into L by A. See, they are asking about resistivity, right? That means the material which will be having more resistance in spite of having the same length and area means that it is having more resistivity. So tell me, out of all of these, which one does not allow current to pass? So no, does not allow current to pass. Resistor allows current, but something that does not allow current to pass, insulator, right? This does not allow current to pass. That means it must be having the maximum amount of resistivity, because if the resistivity is maximum, then it won't allow the current to pass, right? Because more the resistance, more will be the hindrance to current, right? Okay, so this is an insulator. So insulator will be option B, right? This one will be insulator. Am I clear? Because this has the maximum value. Okay, so insulator becomes B, right? Okay. Now after insulator we have semiconductor, a good conductor, resistor. Now let us classify it. See, substances can be of 3 type based on their electrical conduction. Okay, one type is conductor, one type is semiconductor, one type is insulator. Okay. Okay, tell me one thing, does resistances allow current to pass? It allows. Resistances allows current to pass, but if the resistance is more, less amount of current will be passed, but it allows current to pass. So if tungsten is a resistor, then that means it is allowing current to pass, which means that if it is allowing current to pass, then it is compulsory that it is a conductor. It can be a type of conductor which will allow less current to pass, but it is allowing current to pass. This is on the first place, right? So if it is allowing current to pass, then this is a conductor. We get it, right? So conductors can have less resistance. It can also have more resistance, right? It can have less resistance. It can have more resistance. Now, insulator won't allow current to pass. That means its resistivity will be maximum and the resistivity of conductor will be minimum. Who are semiconductors? Semiconductors does not allow current to pass. But under certain conditions, if we can apply certain conditions, then it will allow current to pass. So it is somewhere in between an insulator and a conductor. So generally it won't allow current to pass. If a voltage or if a condition is so produced, then it will allow the current to pass, right? That means semiconductor has resistivity midway between them. So what are the minimum resistivities? See, A and C have the minimum resistivity. Now if the resistance is least, that means in this case the resistivity will be least. So that means it will be a good conductor, right? Conductor can be of two types. One is good conductor, one is conductor with more resistance, right? And then we have insulator or bad conductors that does not allow current to pass. And then in the middle we have semiconductor. So good conductor, bad conductor, semiconductor. Good conductor is a two type, conductor is a two type. One is good conductor, one is conductor with a resistance, more resistance. Okay. Now, so out of these two, both of them are small. So both of them will be conductors. Now tell me, out of them which has the least value? C or A? C has the least value, right? So if C has the least value, then this will be the, if C has the least value, then this will be the good conductor. And the remaining one will be the resistor, right? So good conductor will be C, resistor will be A. Okay, semiconductor. Semiconductor will have the value in between good conductor and insulator. So this will be the semiconductor D. Am I clear? Is the concept clear now? Okay. The electrical resistivity of three materials P, Q and R are given below, right? Now P has a resistivity of this much, Q has this much. Okay, tell me which has the least resistivity, tell me. Q has the least resistivity, right? Okay, which has the most resistivity? R has the most resistivity. Okay, which is in between? This is in between. Now tell me, who has the least resistivity? Semiconductor, insulator or good conductor? Least resistivity. That means it allows more current to pass. So who will be that? Good conductor. So this will obviously be good conductor, right? Okay. Now out of both of them, who will be the bad conductor or insulator? R, because it has the maximum resistivity, right? So this will be bad conductor. Okay. Now tell me, then this will be in between them. So this will be semiconductor, right? Okay. Now let us get into one thing, electrical wires. Now what are the type of material we use to make electrical wire? Good conductor, semiconductor, good conductor, very good. Then which will be that one? Very good. Okay, handle for soldering. Do you want to get the electric shock from the soldering iron? No, you don't want that. Do you want to get the hotness or heatness from the temperature from the heat from the soldering iron? Do you want to get that? No. So if you make a handle for that, will you be using an insulator or a good conductor? Insulator. So this one will be. Tell me which one? R. Very good. Okay, solar cell. Now solar cell are made up of semiconductor materials, right? So if it is made up of solar semiconductor materials, then this one will be P. Are we clear? Okay. Can you give the reasons on your own? Okay, very good. আর বলেছে total current flowing in the circuit. Acha. In the circuit diagram given below, 5 resistances 10, 40, 30, 20, 60, 10, 40, 30, 20, 60 are connected as shown in figure to a 12-volt battery. Okay, total resistance of the circuit. Acha, total resistance, how do we find out total resistance? See, if I take two terminals, this is terminal A, this is terminal B. Okay, now can I break it in this way? See, from A I am writing here. See, if this is A, this one will also be A, right? Because there is no resistance in between them. If this is B, this point will also be B, because there is also no resistance in between them. So can I write it as, see, this one, and with that we have three resistances, this one, and this one, right? Can I write it in this way? So if this is 10 ohm, this is 40 ohm, this will be 30 ohm, 20 ohm, 60 ohm, right? Can I write it? Okay. Now, see, tell me if we, whether it is in series or parallel. Parallel, and this one is also in parallel. So let us do one by one. So if it is in parallel, can I write it as R parallel 1, and can I write it as, this is also in parallel, so that is R parallel 2. This is B, this one is A. Okay, first let us find the value of R parallel 1. Can I write R parallel 1 by equals 1 by 10 plus 1 by 40, because it is in parallel, right? So can I write this as 40, this will be 4 plus 1, so that will be 5 by 40, 5 8s are 40, or can I say R parallel 1 will be 8 ohm. Can I say that? Okay. Similarly, if I find out R parallel 2, how will I do that? See, there are three resistances in parallel, right? So can I write 1 by R parallel 2 will be 1 by 30, 1 by 20, 1 by 60. The LCM will be 60. So that will be 2 plus 3 plus 1. So that will be 6 by 60, right? So that will be 1 by 10, or R parallel 2 will be 10 ohm. Are we clear? Okay. Now, so this is 8 ohm and this came out as 10 ohm. Okay, tell me, are they in series or parallel? Series. Okay, very good. So if they are in series, can I write them as a single one? So that will be 8 plus 10, or the answer will be 18 ohm. Are we clear? So what we found out here is that the resistance that we imagine between A and B by replacing this one has become 18 ohm, right? Now they are asking us about the total current flowing in the circuit. So A, we have got 18 ohm. They are asking about the current flowing, right? So what will be the current flowing? The current flowing in the circuit will be V equals to IR, or I will be equals to V by R, right? Or V is 12 volt, R is 18 ohm. So 6 are 6 3s are 12, 6 2s are, so that will be 0.67 ampere. Are we clear now? Okay. Let us see this one. Now they are saying that in the circuit given below, we have been given two resistances. One is the 3 ohm resistance, another one is the 6 ohm resistance. Now, what is the combined resistance? Tell me, are they in series or parallel? Parallel. So how we find out the combined resistance? 1 by R parallel will be 1 by 3 plus 1 by 6. So that will be 6, 2 plus 1, or 3 by 6, or R parallel will be simply 2, right? What is the potential difference across the combined resistance? So what happens is that we are imagining this one as a single resistance, right? So can I write it as, we have a series of battery here and we are replacing it by a single resistance whose value is 2 ohm, and 6 ampere current is flowing through it. So if 6 ampere current is flowing through 2 ohm, then what will be the voltage difference across it? Tell me. By Ohm's law, V equals to IR, right? I is, very good, 6 ampere. So that is 6 times 2, that will be 12 volt. Are we clear? Okay. Next they are saying what is the potential difference across the 3 ohm resistor. Okay, if they are connected in parallel, that means if I take this as 12 volt, then this will be 12, this one will be 0, right? 12 volt, if it is 12, if it is 0, then only the difference between them is 12 volt. Suppose we have a resistance here. If I say that the potential difference between them is 6 volt, so what can be possibility? This can be 6, this can be 0. Then the difference between them can be 6 minus 0. It will be 6 volt, right? If I say that there are 3 resistors connected, okay, difference between them is 4 volt, this is 2 volt, this is 3 volt. Can I say that? Now we are giving them a supply of 9 volt. How much? 9 volt supply we are giving them. Now if this is 9, tell me what will be the voltage here? No. If it would have been 0, then the potential difference will be 9. What is the difference here? 4. Then what can be the resistance voltage here? Tell me. 5, absolutely. What can be the voltage here? 3, good. What can be the voltage here? Do you get the idea of potential difference? Okay. Now, we come into this case. If it is 6 ampere, 2 ohm is there, 12 volt is passing through them. So, if it is 12 volt, what will be this one? The difference is 12 volt. Then what will be this one? This is resistance. This is voltage. The potential drop across this whole connection is 12 volt, right? That means if the front end is 12, the back end will be 0. Otherwise, how will it be 12 volt? Is it possible otherwise that it will 12 volt? No. So that will be 12, this will be 0, right? Now 6 ampere is passing through it. So that is 12 volt. Now let us take this wire and this end. So what will be the voltage here? If this is 12, what will be the voltage here? Is there any resistance here? Then what will be the voltage here? 12. Good. Is there any resistance here? What will be the voltage here? No, if it is 0, then what will, this is resistance, Baba. This is resistance. See, this one is volt, volt, volt. We are saying about volt. This can be 100 ohm. This can be 500 ohm. I don't know. This can be 50 ohm, right? This can be somewhere like 30 ohm. I don't know, like 60 ohm, 70 ohm. It can be like that. This 75 ohm. I'm not worried about that. Okay, I'm not worried about the resistance. I'm asking about the potential difference. So resistance is a different thing. Potential difference is another thing. Okay. Now look here. It is a 3 ohm resistance. Is it potential difference? No. So if it is a wire, if there is no resistance, then this will be 12. If it is a wire, if there is no resistance, if it is 0, then what will this be? 0. Same goes here. If it is 12, what will be this one? Very good. If it is 0, what will be this one? 0. Then what is the difference here? 12 volt. What is the difference here? Simply, so potential difference across 3 ohm is 12 volt. Okay. And potential difference, they have asked this one only. So have we done number C? So number C is also 12 volt. Are we clear? Now they are asking what is the current in the 3 ohm resistor. Now we have done it already. Okay, see. So for the 3 ohm resistor, this is D part. For the 3 ohm resistor, what do we have here? This is a 3 ohm resistor, right? Some current is flowing through it. I don't know what current is flowing through it. But the potential difference across it is 12 volt, right? We have just found it out. So we know from Ohm's law V equals IR. Now V is 12, I equals small I, R equals 3. What will be I? 12 by 3, that will be 4. Are we clear? Okay. Similarly, what is the current in the 6 ohm resistor? Now across the 6 ohm, what is the voltage? 12 volt. So we can do it in two ways. See, this is our circuit. This is our circuit, okay? This is 3 ohm, this is 6 ohm, okay? Now 6 ampere is coming here. How much current is going through there? We just found out 4 ampere, right? So that means 4 ampere current is going through here. So if it is 6 ampere, 4 ampere is going through, how much is left? 2 ampere. Then 2 ampere is going through 6 ohm. So this is a process, easy one. There is another process also. So this is the connection, right? This is the connection. This is 6 ohm, this is 3 ohm. Now the potential difference we have just found out across 6 ohm is 12 volt. Right? So if I current is flowing through it, can I write V equals IR? Or what will be I? That will be V by R. V is 12, R is 6. Right? That will be 2 ampere. Are we clear here? Are we having any confusion? No. Okay. Tell me about the next doubt. The figure given below shows an electric circuit in which current flows from 6 volt battery through two resistors. Okay, it is flowing through two resistors. Okay, first tell me, are they connected in series or parallel? Parallel, very good. Are the resistors connected in series or parallel? Parallel. Okay. For each resistor, state the potential difference. Now, this is 6 volt, right? Is there any resistance here? then if it is 6 volt, is it that can I write this one as 6 and this one as 0? If it is 6, what will be the potential here? Very good. If it is 0, what will be the potential here? 0. Now tell me, if it is 6, then this one will be 6. If it is 0, this one will be? Very good. Now if it is 6, this one will be? And this one will be? So what is the potential difference across 3? Very good. What is the potential difference across 2? Very good. So you are not going to do it nicely. Very good. You are answering that. Very good. Nice. Well done. Okay. So for each resistance, the potential difference is 6 volt. Okay. The current flowing from the battery is shared between two resistors. Absolutely. Which resistor will have bigger share of current? Tell me. Which resistor will have bigger share of current? First, tell me one thing. You have been given two paths. 100 students are going. One path is very narrow, one path is thick. So the path which is very narrow, it will have very less dimension, like it may be about 1 meter thick, and the path which is very wide, it may be like 10 meter thick. So the resistance, like, no, that's not a good example. Let us give the example in this way. Suppose you are going through two equal roads. Understand properly. You are going through two equal roads. This is one road and this is another road. Okay, the road is branching out from here. Now in this road you put two pebbles, two thorns, and in this road you put three thorns. Now you have 100 people, 1000 people, and every one of them know that there is two thorn here, there is three thorn here. Which path more will choose? Path 1. So the path which has least resistance is chosen by most, right? The path which has least resistance is chosen by most. In the same way it works for the current also. The resistance which will be minimum will deliver the maximum amount of current. The resistance which will be maximum, it will deliver the minimum amount of current. So by seeing only, can we say which one will have more current passing through it? 2 ohm. Very good. So the current flowing from the battery share to which resistor will have bigger share of current? 2 ohm resistor. Calculate the effective resistance of the two resistors. Let me find out the resistance. So how will I do that? Are they in series or parallel? So that will be number D will be 1 by R parallel will be 1 by 2 plus 1 by 3. That will be 6, 3 plus 2, or that will be 5 by 6, or R parallel will be 6 by 5. Are we clear here? Okay, 6 by 5 will be 1.2. So that will be 1.2 ohm. Calculate the current that flows from the battery. So how has our circuit changed? See, so we have this 6 volt battery. We have a resistance here, right? Now this is a 6 volt battery. The resistance is 1.2 ohm. So that is the total resistance, calculating the equivalent one. So can I write V equals IR, or what will be I? That will be V by R. V is 6. R is 1.2. Can I write 1.2 as 6 by 5? So what will that be? 6 will go away, that is 5. So the value will be 5 ampere. Are we clear? Is the concept ekdam clear? Very good. Chalo. For the circuit shown in the diagram below, see, we have a lot of resistances here, right? They are asking about the current through 6 ohm resistor and the potential difference across 12 ohm resistor. Okay. Now let us do it one by one. First we will find out the equivalent resistance. Tell me, are they in series or in parallel? Okay, and this one is also in. So can I write this one as, this is 4 volt, okay? And this one will be 6 plus 3. So what will be the value? 6 plus 3? 9. And this one will be 12 plus 3. So this will be 9. This will be 12 plus 3, 15 ohm, right? Now tell me, are they in series or they are in parallel? They are in parallel. So can I write them as, this is 4 volt and we have one of them in parallel. So this is 4 volt, 9 and 15. So can I write it as 1 by R parallel will be 1 by 9 times 1 by 15. Okay, so 9 and 15. Let us find out the, I think it will be 13 or 60. 16 or 60 also not going. Let us see. 3 3s are 9, 3 5s are 15. So 3 3s are 9, 9 5s are 45. So that is 45, right? 5 and this will be 3. So 5 plus 3 8, so that will be 8 by 45. So 1 by R parallel will be 8 by 45, or R parallel will be 45 by 8 ohm. So we have found out the equivalent resistance. So how can we write the circuit? Can we write the circuit in this way, that we have a 4 volt and here we have a resistance which is 45 by 8, right? Okay, now they are asking us what is the current through 6 ohm resistor, but for that let us find out the value of total current passing through the circuit. Okay, so we can do it in a lot of ways. We can do it in a lot of ways. Okay, we can do it easy way also. So we will do it in many processes. First we will do it in process 1. Process 1 is, we will find the total current. Now this is 4 volt, right? So can I write that I equals V by R, that is 4 by 45 by 8. So 4 8s are 32 by 45. Can I write it in this way? Right? Okay. So that will be 32 by 45 ampere. Now they are asking us what is the current to the 6 ohm resistor, right? So how is the current branching out? This is a 4 volt. Now it has two branches. It has two branches. Tell me, the amount of current that will go through the 6 ohm resistor is the same amount that will go with through the 3 ohm resistor, right? That means if I connect 6 and 3 in series, the same amount is going through the series also. First get this thing clearly. The amount of current going through 6 ohm resistor is same as the amount of current going through 3 ohm resistor. Now if I connect 6 and 3 in series, that means they are along the same line, right? That means the same current will be passing through both of them. Have we got the idea here? Are we clear here? Okay. Now if the same current goes through 6 ohm and 3 ohm, that means can we say that the series connection, this is 9 ohm and 15 ohm. So if I can find out the current through 9 ohm, then that will be fine, right? Okay. Now if I have a connection like this, see, if I have a connection like this, understand this one properly. So there is a resistance R1 here. Write this down in your copy now, okay? If there is a resistance R1 here, this is R2. I current is coming. Let I1 current is going through R1, I2 current is going through R2. Okay? Now if the potential difference across this terminal is V, can you tell me what is the potential difference across this terminal? Potential difference between this end and this end is V. What is the potential difference between this end and this end? V. Very good. Wow, very good. Now what is the potential difference here? V. Very good. Very good. So you have learnt it well. Very good. So can I write this V as I1 R1 and this V as I2 R2? Can I write them? As both of them are V, can I equate them and say I1 R1 equals I2 R2? Or can I say that I1 equals to, okay, there is I2. Can we also say that, see, I is getting divided into two currents, right? So can I say I equals I1 plus I2? Can I say that? Now, can I say I2 equals I minus I1? And can I put this one here? So I1 R1, putting in place of I2, we get I minus I1 times R2. Because we are putting I2 equals I minus I1. Or can I write I1 R1 plus I1 R2 equals I R2? Okay. Can I write I1 R1 plus R2 equals I R2? Or can I write I1 equals to I R2 by R1 plus R2? Can I write them? Okay. Now if I can write them and go to this numerical. Now this I is 45, this I is 32 by 45, right? This is the I. I want to find out I1. This is I2. I want to find out I1. What I will do? I1 equals to, see, I into R2. What is I? 32 by 45. I into, what is the formula? I into R2 by R1 plus R2. This one is R2 then. And R1 plus R2 the sum of both. So what are we getting? Equals to I, that is 32 by 45 into R2, that is 15. By R1 plus R2. R1 is 9, R2 is 15. Are we clear? Okay, so what are we getting? 32 by 45 times, see, 15 by 9 plus 15 is 9 plus 15 is 24. 8s are 8 4s are 32, 8 3s are 24, right? 3 5s are 15, 5 9s are 45. Or can I say I1 equals 4 by 9 ampere? Can I say that? Okay. Similarly, if I get I1, they are asking me current through 6 ohm. So current through 6 ohm is I1. That means that will be 4 by 9 ampere. Now, next question. Next, we can do it in another way also. There are various ways of doing it. Another way of doing it is, let us first make this clear. Okay, let us first make this clear. So, this is 4 volt. So, can I write it in this way, that we have 4 volt and the 4 volt is connected such that here is 9 ohm, because I am actually making the series combination of 6 and 3 and making it 9, making it 15. So this one is 9 ohm, this one is 15 ohm, right? Are we clear? Now, if it is 9 ohm and this one is 15 ohm, the potential difference across this terminal will be, tell me, what will the potential difference across this terminal? 4 volt. Good. So what are we getting is, we have 9 ohm, right? The potential difference is 4 volt, right? Can I find the current through it? Of course. Or I equals to V by R, that will be 4 by, I will be 4 by 9. Now the I we have got is 4 by 9. If I distribute it into two parts, one is 6 ohm, one is 3 ohm. That means the current through this is 4 by 5. That means this is the same current that is going through 3 ohm. So the current through 9 ohm in series is same as the current going through each component of it, right? 6 ohm, 3 ohm, or whatever we sum to make the 9 ohm. Is that clear? Okay. Next question is potential difference across 12 ohm resistor. So where is the 12 ohm resistor? Here is the 12 ohm resistor. So if I find out the current through this branch, and if I multiply the current with 12 ohm, then I am getting the voltage across that. So first we will find out I2. Now we have already found out I1, right? We know I equals I1 plus I2. So can I say that I2 equals I minus I1? Can I say that? Or can I say I2 equals, I is 32 by 45, right? 32 by 45 minus I1 is, what is I1? I1 is 4 by 9, right? So that will be 45, and this is 32 minus 5, 5 fours are 20. So that will be 12 by 45. If I cut it by 3, this one will be 15 3s are 45, 4 3s are 12. So the answer will be 4 by 15 ampere. Okay. Now the current through 15 ohm is 4 by 15, right? That means this is the same current that is going through 12 ohm, because 15 ohm is made by adding 12 ohm and 3 ohm altogether. So if the current is 4 by 15 ampere and if it is 12 volts, so what is the voltage? Simply 4 by 15 times 12. Are we clear? So if I deduct it, this will be 4, this will be 5, that will be 16 by 5 ampere. Huh? 16 by 5 volt. Yes, now it is okay. Okay, 16 by 5 means 5 3s are 15, 1 means 5 5 2s are 10. Okay, so that will be 3.2 volt. Are we clear here? Are we having any confusion? No. Please check the answers and confirm me. Okay, a battery and 3 lamps are connected. Okay, what does this symbol mean? This is a symbol of a lamp, right? Now, if there is one lamp, suppose one lamp has resistance 10 ohm, then this will be 10 ohm, right? Then this one will also be 10 ohm. This one will also be 10 ohm, right? First get this clear. If this is 10 ohm, then this is 10, this is 10. Now tell me one thing, this is connected in series, right? Then what will be the total resistance of this portion? Tell me. 20, 10 plus 10, that will be 20, right? So we can reconstruct this figure as, see, this is the battery and here we have a resistance of 10 ohm and below we have a resistance of 20 ohm, right? This is a battery. Okay, now tell me, if a current is coming here, it will get divided into both of these branches. Now this current is current X. Now this is divided into y into z. Okay, just before some time we did one thing. The least resistant path allows maximum current to pass. So which path has least resistance, y or z? Y. So the maximum current will pass through y. Then the minimum current will pass through z. And out of all of them, x, y and z, x is the sum of y and z. So x is obviously greater than y and z, right? Because x is equals to y and z, right? And z is less than y. So obviously x is greater than both of them. Now, which is current? Current z is greater than y. Is current z greater than y? No. So this is wrong. Current at x equals current at y. This is obviously not. Because x, and if we consider x and z and y, see, y and z are part of x. Now, it may be possible that x equal to y. In that case, z has to be 0. But is there any situation where z can be 0? No. So this is also wrong. The current at x equals the current at z. Obviously not. Now, the current at y is greater than z, right? Y is greater than z. So this one is the right answer. Okay, chalo. So you are given 3 resistances, 1, 2 and 3 ohm. Now, show by diagrams how with the help of these resistances you can get 6 ohm. See, can I connect all 3 in series? So if I connect all 3 in series, this is 1, this is 2 and this is 3. So series resistance will be simply 6 ohm, right? It's very easy. Chalo. Next, 6 by 11. See, 6 by 11 is less than 1, right? Now you have to remember that in parallel combination, the smallest resistance, okay, this is the smallest resistance. Now if I combine this in parallel, the effective resistance that will come will be always less than the smallest resistance. Similarly, in series, the effective resistance that will come, it will always be bigger than the maximum resistance. You should keep this in mind, okay? Now, so if I connect them in parallel, so this is 1, this is 2 and this one is 3, right? So if I combine them, 1 by r parallel will be 1 by 2 plus 1 by 3 plus 1, right? This is 6, so this will be 3, this will be 2, this will be 6. 3 plus 2, 5 plus 6, 11 by 6, or r parallel will be 6 by 11. Is that clear? Okay. Now, next is 1.5 ohm, right? So how will I get 1.5 ohm? Now this, it's very interesting. See, if I connect it in this way, that there is 1 ohm, there is 2 ohm, and at the bottom we have a 3 ohm. This is 1 ohm, 2 ohm, and here we have 3 ohm. So can I write it as we are having 3 ohm on top and we are having 3 ohm on bottom? Can we write it as this one? So these are in parallel, right? If they are in parallel, we can simply write 1 by r parallel will be 1 by 3 plus 1 by 3. That will be 2 by 3, or simply r parallel will be 3 by 2, which is 1 by 5. Okay, remember one thing. It's a note for you. Remember this note, that if you have many resistances connected in parallel, many. Suppose you have n resistances connected in parallel. How many? N resistance, okay, and each having value smaller. Each resistance has value smaller. So there are two conditions. First is the resistances must be same. Second is there are n resistance connected in parallel. Then the equivalent resistance Rp is simply R by N. Okay, simply R by N. This is a formula. It will be helpful. Okay. Similarly, in case of series, if there is one resistance, two resistance, in this way, there are n resistance. How many? N resistance. Then what we will find out? R series will be simply n times of smaller. Okay. Are we clear? Do we have any problem with that? No. Okay. Chalo. So I am keeping it down here. So see these numericals. Do the numericals that has not been completed yet. And I'll be giving you some more worksheets, so complete that and come next day. Okay, we will be solving the problems that we are having. Okay, chalo, done.